Hello and welcome to stream number 81 in the series where I am programming an NES game live on Twitch from scratch. In the last stream we got a lot accomplished. I was able to get the change done that allowed us to switch over to the new save format that we needed for our sprites so that I could import tiles from the sprite at arbitrary locations. So I could import this sprite, even though it is, even though you could have it be the full 16 by 16. Instead, it is now just 3 8 by 8 tiles instead of wasting some char space. And that was accomplished by using our JSON configuration files that we can import, these metadata files that now we can use to put in the positions of the sprite in the PNG for when we go to do the conversion and the creation of the sprite. The sprite file that we use for the actual export to the game. So now the part that I've been kind of putting off a little bit has been the changes to the sprite palettes. I mean, I guess the background palettes too. In both cases, we are just kind of brute forcing the palettes. Although I have a bunch of palettes here in the actual map. If you go to this guy here, you can see that we've got all of these, but we don't actually use them all. Oh, I'm sorry. No, that's not true. We've got no, I take it back again. So we do use these, but we don't use this gradient tile set anywhere. And so we have blue tile, green tile, and bumper. And so we're okay as far as the number of palettes we're using for the background. But the challenge there is that if we wanted to go with something like including a fourth or fifth meta tile in the map, we don't know if we don't handle the palette sufficiently, and similarly with the sprites in the quote-unquote project file that defines the map and brings in the sprites that we are using. We have these three, which are the explosion, the bullet, and the player. But we also have in the map two additional sprites. We have the flyby and the flyby 2. So that's 5 sprites, all with different palettes, and we don't handle that properly. And so when we go to load the game up, if we look at our palettes, we have this palette for the explosion, we have this palette for the bullet, we have this palette for looks like the player, this palette for one of the flyby entities, which is this one. This one is now just looping back and using the explosion palette, and we can verify that by actually modifying the palette to see how it changes. So if I go and change this to, hot pink, you can see that it's changing the colors there. So while it's good that we don't have a problem that it's, breaking the game when we try and import that data, at the same time, we need to see if there's a way that we can properly handle how many pallets we have loaded. And so I've kind of been thinking about this a little bit, but it's one of those things where I think I'm not going to know what I need to do until I start to kind of implement it and mess it up and and it doesn't work, and then I've got to try again or fix it or whatever we're going to do. So let's talk about what we're actually doing here. So at any point in the map, we have at least the player sprite. And the player sprite is really going to be divided up into 2 pallets based on the artwork that we got from Jordan. And I realized that I can, for those of you who might be irritated that I keep opening and closing lots of things while I describe it, and I don't, maybe I don't need to, I don't know. At the same point, I want to have this visually represented so people can see, because I know what I'm talking about, but it may not be clear from everybody's perspective when I'm just talking about it. So this is 1 pallet. Actually, he did a nice job of breaking it down. Where was it on this page? Yeah. So he did a nice job of breaking it down into pieces, right? So the main body of the ship is this pallet, these 2 grays and red. And then the cockpit is the gray, the white, and the blue. So the challenge we face now is we're already consuming 2 of the 4 pallets we have for sprites by splitting up the player like that. But at the same point, I kind of like, or I really like the way that this looks. So does that then, maybe I'm overcomplicating this. Maybe I'm thinking about doing something that's far too unrealistic. Like, for example, well, let's see. So he used this pallet for firing weapons. And if that's consistent for the enemies, then maybe that's, yeah, that's just a pallet rotation. So if that's consistent for all of those things, that's 3, and then the enemies are a 4th pallet. Maybe we don't need to swap it dynamically. Maybe I just need to, maybe we need to just simplify it and have a preset pallet configuration that we load in for all of the pieces of the game. And then if we need to swap, like if the enemies need to, for example, change color for a different part of the game, we just do that. We can put something into the map itself that allows us to do that. But instead of making this whole convoluted scheme where we are dynamically cycling in pallets, because it'd be one thing if the ship was just a single pallet, but because the ship is already 2 pallets, now we're really talking about 2 pallets that we have to work with. If we keep all the explosions and bullets and thrusters consistent, and the enemy stuff consistent, yeah, you know, that might be a better approach. Again, not saying we're not going to cycle pallets out at certain points because we need to change the look of the enemy depending on what we're doing. But it gives us an easier way of handling this, and I don't know that we need to overly complicate this right now. If it comes to a point where we have some sort of scenario where the game requires something special, we can tackle that. All right, so now what we're basically saying is let's do this. So trying to think of what the appropriate way of handling this is. If it should be I mean, we can sorry, I'm considering this before I go too far down the road. But basically what I'm wondering is the trade-off of, do we define the palette externally from the player configuration here and import it into the sprite, where the sprite is referencing an external palette that is then simultaneously loaded by the project file here? Or do we embed it in the sprite itself? Right now the palettes are actually part of the sprite, but we'd have way more control. We'd have way more control if we didn't do that. So what I'm thinking is, this might actually be a lot easier. If the definition of the sprite, right now we have the tile locations, right? And for each one we have an X and a Y. We were saying we would have some sort of palette value. Maybe that palette is, for now, we have a palette ID, and then in the map itself, or the level itself, or the game itself, for each level, we say, you know, level 1 has this beginning palette called, you know, Sprite palette. And that's just our definition of the standard NES colors here. We can, you know, define the actual color value there, and then this way, when we go when we store the sprite information, we don't have to store the palette colors. We look it up based on what palette 1 is. The only thing is, palette 1 in and of itself doesn't mean anything if you just want to view the sprite, so maybe we also have to have the palette name just for reference. And then that's the same name that we're referencing here in this level definition. That way we can say, okay, we have our palettes and palette name as part of the JSON. They map over to what's in the level. We know that the palette index can only be 0 through 3. And if you try to use too many, then it won't work. And then, you know what, that also gives us a nice way to sort of match up between the map and the sprite, where we can say, okay, palette 1 is this palette name, right? And then when we load in the sprites, we can say, uh-oh, wait a minute, there's a mismatch here. and we can have some sort of warning get generated that it's not going to look right, at least for the initial load. There may be game logic or map logic that we add later when, like, we may want to put something where in the object layer, instead of just having enemies defined like we have currently, we might want to say, okay, we want to add something, we want to add a new object layer and call it, you know, pallet, right? And in the pallet layer, we can add a new object for what we want to swap the pallet to, and we can give a pallet ID, and that pallet ID will correspond to the list of pallets we have available. Yeah, that might work. Let's give that a try, and then we can adopt a similar mechanism for backgrounds. And then the additional thing is that we benefit by the palette will define the colors in the appropriate order we want, with the background color being not one of the colors of the sprite. But then we can do our little RGB YUV mapping to the NES colors to transform the RGB PNG values into the appropriate index from the palette. Yeah, the more I kind of talk that through, the more that seems like a better option, just because of the limited number of palettes we have. If we were able to have a few more palettes, well, I mean, that's I mean, at some point it's like the number of palettes becomes irrelevant, because now you're talking about 16 or 32 colors or something like that, and then the system would probably have been designed to just support you know, an arbitrary palette system where the pixels were not defined in 2 bits like they are for the char-ROM, and you'd get something like, I forget if the GBA is using indexed color. I believe it is. I believe it's using indexed color. But anyway, you'd get some sort of indexed color where you have, you know, more than 2 bits to define your pixel, and then more colors available. So anyway, and then we should probably look at bringing in these enemies, or at least like this one. Just one would be fine. Assuming I know how to do that in a Sprite. Where do I see? Okay. So it's 16 by 16. Actually, is it really 16 by 16, or is it smaller than that? We can kind of, excuse me, kind of chop it as we need to. It looks like it's 8 by 14. Excuse me. So we can oops. Well, let's do this. Let's create a new PNG. That's 8 by 16. What? Here, let's change this for a second. Go back to RGB, please. I don't need it to... Did I get everything? Looks like there's just some... There's an errant pixel there. Alright. Yeah, cool. So it fits nicely into that. And we can save that. Let's call it, I don't know, gunship. Or Scout. Not that it really matters what the name is right now, but all right, so we have that, and then what I want to do is I want to switch to indexed, except that the palette is the wrong one. Let's go to I know there's a way to do it. I always forget. That's the default palette. Palette for palette size. I gotta play around with this more. Oh, presets, here it is. I'm still pretty bad at using this. Just because I'm not used to it. I'm used to Photoshop from stuff that I've done at work, but not exactly ideal. In fact, Photoshop makes this all a lot harder than just using something like a Sprite. All right, so now let's go back to indexed mode, and now we at least have colors that are close to, or should be the same as the NES. All right, so now let's create in our assets folder. Create something called Scout JSON, and that will define okay. That doesn't really do that much for us. Let's convert it and export it and tweak it. Okay, so oops, wait a minute. That's not what I wanted to do. Okay. I screwed that up. Sorry. No, I almost did it again. Don't do that. Bad. Okay. So let's do PNG to Sprite. What do I call it? Scout.png. And interesting, so it only got the first tile. Why? All right, let's see what it did here. So there's the bounding box, and there's the sprite position 0, 0, and 0, 8. That actually looks right. Why is that drawing wrong? Also, why? Sorry. Very fidgety today, I guess. All right, what is making it only draw that first? I mean, it works. Is it only drawing square things properly? It's entirely possible. That would be funny. Draw, oh no, sprite to image. Draw sprite? Okay, draw sprite. Is it drawing? That's the top of the ship. So, what is it doing here? Let's see. Sprite width is 8. What is the sprite height given as? It's 16. So the image it's 8 by 16, so that looks good. Temp X. So we should go into that twice. Where now temp is equal to 0.8. That's fine. And so let's see. So I times 64 plus x plus y times 8, which is right. I wonder if it's just a drawing problem with the image itself, because this all looks correct. Let's see. Draw image. All right, let's see here. What's going on? Image ID, current image width 8, current image height, current image height, image width, image height, current image, selection, image changed. Let me just try something here. What is it? It's screen. I just want to try blitting it right directly onto the screen to see what it actually is. Destination, source, width by height. It's 8 by 16. Gotta restart this. Let's see what's going on here. Now we changed this code in the last couple of streams, so it's possible that something here got broken. Oh, you know what? The scaling factor might be, because it's scaling by, what, times 16? Let's try this. No? What's going on? Destination, source, destination X, destination. I'm confused as to why this is behaving this way. Oh, I know why it's behaving that way. Because we are overwriting that at the end, and so it doesn't matter what I'm blitting onto the screen, it's going away. Let's fix that. Let's do that after the update. That'll help. Or not. Really? Sorry, I'm trying to, there we go. Oh. Okay. There it is. Oh, it's just really tiny. There it is. Okay, so it is complete, although quite small. So that's good. And that is less problematic than I thought. That means that the image is okay, but something is preventing the whole thing from being drawn. What would that be? That was the wrong key press. All right. Render image. Let's see, Tiger Blit. So it's multiplying by the scale. Really? Have I never? Let's see. If I make this 80 by 160. Why aren't you scaling? Tiger Blit. Oh. Well, that's the problem. It should be DH and not DW. Don't know why that's not scaling properly in that call, but that should fix it. Yeah, there it is. So that was just a bug. That was a simple typo. All right. So, all right. So now that that's loaded, that actually looks decent. We have our sprite, and we should do what we were talking about earlier. Sorry that I'm like kind of half distracted here as I'm thinking about this, so it's dragging on a little bit. All right. So let's start with this guy because it's easy. It's using just the one sprite. And we're basically going to say, we're going to have a property called pallet. And we'll call the pallet enemy.pal, right? Pretty straightforward. Now, I had originally said it would be a numeric value. But I think I want to leave that to the asset tool to determine the numeric value, just because it shouldn't be fixed. It shouldn't matter what the value is, as long as it's consistent for the map and the gameplay, the duration of the gameplay. So, and then what we can do is let's see, how do I want to do, what's the easiest way to do this? Right now, when we render we have our palette view and we're iterating through our palette and just drawing. You know what would be nice is to have the actual palette value what is it? It'd be nice to have the palette value, the color code on the palette, so that we have access to that without having to look it up. Why can't I? Oh, tiger print. So we want to put that on the layer. We want to put that on X and Y of that node. What I would say, we probably want to use some sort of inverted color so that it stands out on top of the color. Yeah, on top of the color of the palette. For now, let's just use white, and the text will be the hex value of the index value here, if I can type. So it's temp, and then the format is what is it for that? It's, what is it, 0.2x, like that? I think that's how that works. It's been a while since I've messed with that. And then we want node palette data palette I semicolon. Let me just double check that because I don't remember. Format spec. Yeah. So that should give us what we're looking for. Let's take a look at that. Oh, it's currently open. That's not going to work. Oh. Well, that's not going to work either. We want to move it over so that it is on top of the current palette item we're drawing. Okay, that's pretty good. I'll take that. And then we want to do the same thing on the palette view where we're drawing all the palette colors. So let's do that. That is, yeah, so, oh, not the palette view, the color selector. Here it is. Okay. Yeah, good work. Let's take that and move it over here. And then take that and move it over here. And then our, let's see, our palette is, color index is that. I is undefined, oh yeah. Although we want to change this to just match this guy. If color, oh. Really? No, I'm probably doing. Oh. Duh. Okay. So now the only other problem is the UI isn't changing as well. We'll get that fixed. Okay, there we go. That actually looks halfway decent. Maybe I don't want it necessarily right in the corner there. We'll do like +4. I was going to invert the colors just so it stands out, but the font does a pretty good job of making the text visible even out in a white background. So I think I'll take that as is and then add the +4 here. Oops, wrong spot. The +4 here as well. Cool, and then I can, if I change it, it updates. Awesome. Now that looks cool too. Neat. All right, so the whole point of that was to be able to do a real simple thing like this. So I can say, well, we don't want to use 0D, so let's just use 0E, 102A, and 2D, and that is our enemy palette file. Right? The end. That's super easy. And maybe at some point we'll put that into the asset tool, but probably don't need to. All right. So let's take a look at the player here. Let's load that guy up. Cool. So now we can do the same thing. We can say, all right, 0E for the background, and then the only challenge here is that we are only rendering the 4 colors of the palette. And we said that we changed the So what we did was we changed the sprite to allow for the maximum number of palette colors, but the palette color selector only reflects the 4 that we originally decided we wanted to show. So I'm going to fix that to show the 16, because that's going to be important for us to be able to change things and see a little bit better. For example, in the case of something like this, where, well, that's interesting. So it's, okay, it looks like it's not actually leaving those 4, the additional colors in the palette, even though the image is being rendered properly. So let's fix that. Well, how's that possible? Because that would mean that the palette... Is there just a bug in this? 0 to 16. Palette data. Oh yeah, you know what? I bet I know what it is. Render palette view. It's probably only copying 4 bytes. Yep. I don't remember if that's defined there or not, but let's see. Yeah, I didn't think so. All right, so let's call this const unsigned char palette size equals 16. There we go. All right, so obviously we're not using all of the colors, and the intention is not to support using all of the colors, but again, if we are in a situation where we are, we have a sprite that's composed of essentially multiple sprites with multiple palettes, like we do for the player, we might do that for the enemy, right? Like we might say, okay, an enemy can actually be composed of the enemy palette and the top palette of the player. You know, that gives us some capabilities, and then we can work with that if we allow this. Now, obviously, we would have a problem if we had this and all 16 colors were used, but I'm okay with this. So okay, so then what we would want to do in this is we would want to do the same thing as we did with the scout ship, and we say palette is player top.pal, and then player bottom pal. And okay. And then we have to define what those are, right? So just like we defined the enemy palette, if we then do, let's just say that's that. Then we say, okay, 0E 040010, that's player top. And new. And then this actually is good because it gives us the opportunity to address the fact that, for example, the second palette should have essentially a gap in it, right? Of this should be black, and that, or the color that is not something we want to mess with. We want to actually make it 0E203A. Actually, wait a minute. No, I take that back. What we want to do is we want 0E. We have the light gray color, which is 10, and then 20 for the white, which is the reflection in the cockpit, and then 3A, and that's player bottom pal, right? So that's that. So now that we have that, we should be able to take this and change the sprite format again. All right. So instead of having the palette hard-coded like this, what we instead want to do is we want to change tile positions to be its own struct. And it will be a vector2b, and that is our position. And then it will also be a palette name, and yeah, I don't even. I was gonna make it smaller, but it doesn't really even matter. We can give it a full. This part isn't going into the NES, so we don't have to worry about it being a lot of extra unnecessary characters. So this now changes to be an array of tile positions, which of course now breaks anything that's doing anything with the tile positions data. So that allocates that, that allocates that. And this now becomes position X, and that becomes position Y. And this is size of tile position times number of tiles. And then we need to get property value as string, JS code tokens index max tokens, palette, oops. that doesn't need to be, that doesn't need to be a pointer, does it? Well, it is a pointer. It doesn't need to be, I don't need to get the address that way, because it is already a pointer to the buffer. So what is missing? Oh, the maximum size. Okay, and that's max size, max folder, file folder name. Okay. So that gives us our palette name. That's good. Let's see what else. Tile positions. That's okay. This should be tile position. This should be that, and this should be this. Memset tile position 0 size. This should be this. Read the tile positions out of the file. That's all good, because that's now, yep. So then this should become a tile position, which means that we are getting position X here. And position Y, same thing with these guys. All right, and then this becomes a tile position as well. And we are then writing a tile position, and this is no longer correct. We will have to figure out a solution for this in a minute. Let's continue on making the changes for the tile positions. So that's that, and then let's see, so this becomes position.x and position.y, and this is, we're reading the image data in, so that's fine, that doesn't have to change. This does, because this is no longer the appropriate sizing. That is okay. This is wrong. And this is wrong. And this becomes position.x. And that, and that, and that. And that is going to be fixed in a moment or so. That's that. So we're just going through and updating all these references to the tile position data, which is no longer correct. The nice thing is that we do get some benefit of the compiler helping us here and flagging all the things that are no longer valid because of the changes we made. But there are some little insipid, I think that's the right word, little things that are less obvious because the compiler doesn't really know, because we're manipulating the memory directly. These are the things that people complain about when they talk about the dangers of using memory access directly, is that you have to know what you've done to know if you've made a mistake or not, instead of letting the code handle it for you, or the compiler, I guess, handle it for you, which has its pluses and minuses. I mean, certainly it's nice to not have to worry about it at times. But sometimes you want to worry about it, and sometimes it's really not that big a deal as long as you're paying attention to what you're doing to get that done properly. Here, so like this is wrong still, and this sizing is still wrong. So that's fixed. Let's see, where else? I mean, I'm certainly not saying that modern programming languages that handle some of these things for you are bad. I mean, if you're doing high-end performance stuff, they can be, because you don't really know what's going on. And ideally, you're kind of always working on stuff that you want to have perform well under all circumstances. But the reality is that most employers are more concerned with the code being done quickly and correctly than they are with the code being as fast as possible, unfortunately, until it becomes a problem that a customer complains about. At which point then you kind of have to unravel the mess of all the things that have hidden various problems from you over the course of, you know, however many months or years of development, and then you have to figure out why your code is slow. So what I'm thinking I want to do, I don't want to store the palette in the Sprite file anymore, because it's really no longer relevant. But that doesn't mean we don't want it associated with the Sprite, because it's convenient to have that loaded into the Sprite and then referenced. So what I'm thinking I want to do is this. Actually, sorry. I actually want to do this. And the reason I want to do that is that it means that then we can, similar to what we're doing here, null out the pointer to it. So we just write a single null byte. But at runtime we can use it. Right, the business code is slow because it's made in Java. I mean, that used to be more the case. I think Java at this point is actually pretty fast. It can be. Just like C# used to be really slow compared to natively compiled code. But at this point, I think the difference is not quite so great, especially with hardware being as fast as it is. So, all right. So now, let me think about this for a second. That change is okay. Except that we just need to do this. I mean, yes, I was pulling your leg. There was a lot of progress. Yeah. No, there definitely was. It has been a lot of progress in the last 20 years. I remember I'm dating myself now. When I started in college in 1999, they had just switched over to teaching Java. And it was not particularly good, but you know, it was a thing that people saw a lot of promise in, and so that was what was being taught. But yeah, Java, C#, they've come quite a long ways, and in my experience as a programmer, like I was saying, the main thing is that for work that you're doing where performance isn't key to the acceptance of the product by the customer, I mean, there's always some minimum viable performance that any customer will accept, whether that's a game running at, you know, 30 frames per second, or a database application retrieving queries. There's always some sort of kind of measure of minimum acceptable performance that, as a programmer, you're kind of making the call on, and sometimes you're right and sometimes you're wrong. But what I've found is that employers in particular don't necessarily care about it as long as the customers aren't complaining. And again, I think that applies across the board, but the problem is that in certain fields that performance is, you know, your customers, whoever they are more sensitive to that performance issue. So oh, you know what? Actually, I don't want to do that here. And in games, we know gamers in particular are extremely sensitive to performance. And if you don't believe me, you can go look up things like all the thousands of YouTube videos that people have posted related to performance of games or lack of performance in games. And even things like input lag, right? Things like input lag, people are extremely sensitive to, or at least claim to be. I mean, I'm sure there are some people who are, but, you know, down to the point where they're saying that they can determine the difference between 5 and 30 milliseconds, you know. But Pascal and Clipper, yeah, so right, but before Java, Pascal was also what they were teaching when I was in school. They had just switched over. Let's convert image to index, load image palette. Create Sprite, load Sprite metadata, and then create Sprite. And okay, so here's where this differs. The copy can happen, but it doesn't actually matter. So let's see. Oh, okay. But the problem is that's the problem. So we need to allocate our memory for new Sprite, pallet. Okay. And then once we're done, we want to, if not initial data, let me look at this here. If we have the initial data, we're just copying the pointers. But that's because we are... I actually wonder if we need to even do this now. So, sorry, I went on a rambling discourse of that without paying too much attention to what I was doing, and now I've lost my train of thought. So this is, we don't need to do the copy of the palette anymore because we have it in the name of the palettes in the tile positions. This is so we can free them later, which we don't care about here. We have our initial data, or we don't, doesn't matter. The main thing just to make sure of is that the palette is null, which it should be technically, but just in case, I think that's all good. For business code in general, it doesn't make sense to make code in C++ unless performance is the main factor. Applications have Java to be quite fun. Yeah, so yeah, exactly. The C++ isn't really as considered as necessary anymore for performance in non very specific niche businesses. So, like video games. All right. Let me think about this because I'm, like I said, I kind of went all over the place. So this is actually not, let me think. Do I need to do that? I don't need to do that. This is going to load the palette. This is going to do that. This is going to copy the current palette. It's passing the current palette, but it doesn't actually need it because we're not storing it. I guess we could not pass that parameter since it's not necessary anymore. Let's see what I broke by changing that. Okay, cool. So we don't need that anymore. The only thing I would say is that we need to change how we output our or you know what, maybe no, all right, sorry, I was just thinking of something. I'm like, well, if we don't have the palette as part of the tile the sprite position information, then we need to have something that indicates the name of the palette that we're referencing. We have to generate a palette file potentially. I was thinking, oh well, we could generate it from the image data we load. You know what? Let's do that. The only challenge there is we don't know. Well, we'll fix that. Let's do that because I actually think that there's some benefit to doing that. uint8 palette count. So we're going to add this, and then what we need to do is when we load our image palette, right now we're just loading it, and then that's it. Well, what I want to do is I also want to have include the palette count, or the color count, really. I think I turned off the... Oh, let's see. Oh, right. Okay, so now we're only doing this if we exceed the 16 colors. Which is fine insofar as what it is. Okay, so then what we also want to do is set the palette count to be color count. So basically we want to say, okay, set the number of colors, and let's change the type here to match. I mean, it's essentially the same thing, but went to the trouble of defining the type. Let's use it. So we want to return back how many colors we actually used, because we're gonna need that. Come on, dummy. All right, so we have our color count. We have our current palette. Did I put that before or yeah? So color count. And what we're going to do is we're going to generate palette files if we are if we're not using the initial sprite. We will generate our own palette files and associate them to our sprite that we're creating, so that we have at least the default set of colors. And then if we know that that palette is going to be reused, we can rename it and reference it by exporting the JSON and then recreating with the JSON the sprite, and just use that moving forward. Alright, so we have this, and if we are not doing the initial data, then what we want to do is we want to go from I to the color count, and or what did I call it, palette count. And we actually just want to create a bunch of 4-byte files, essentially. And let's see. I want to call, how do I want to do that? I'll do that in here. Okay, so the palette temp, that's 4, and then that's our file name that we're going to use, and we're going to copy to palette name. And then replace the extension to .pal. Actually, do we want to do that, or how do we want to do this? Remove file extension, and then, okay, yeah, and then what we'll do is we'll generate the new file names as we go. So we have our 4-byte buffer. And what we're going to do is we're going to do memcopy. We're going to do plus equals 4. And we're going to copy from palette, from palette I, into pallet temp. And then we're going to create what is the file type of that thing? Is it just file handle? Yeah, file handle, pallet file. And we'll say system hooks, create file, and then pal file name. And that's not the right syntax. Okay. Yes, I know that doesn't exist. Pal file name. And we are going to compose this name based on the base file path without any extension, a digit, and .pal. And so we have pallet name, I is our digit, and .pal is always the same. And we need a max file folder name as our maximum string size, and that needs to be capitalized properly. So we have that, and then we're going to create the file. What's up, compiler? Oh, I reversed the parameters. Okay, and then just a simple 4-byte write. System hooks write pallet file pallet temp size of uint 8 times 4 system hooks close pallet file. Right, that's our pallet file that we're going to generate. And so we'll get, you know, for example player0.pal and player1.pal, and however many colors we have, we'll generate pallet files for that. If we have the initial data, we don't need to do this. Let me think about how this is going to work in terms of the tile position. What I would say we probably just want to do is default it to the first one. Let's see. So I want to keep this around because I'm going to use that further down here, and I'm going to need a temp like we had before. Actually, we could just reuse this then. We don't have to allocate it every time. So pal file name, so string sprint fs pal file name, max file folder name, the base file, the 0 and .pal. What do I call that? Palette name. Again, we're kind of hard coding this because for all intents and purposes, this is probably not what we would end up using anyway. But we need to set it to something. The main thing is that it has a value. so that when we bring it back in or export it or whatever we're going to do, it needs to have that palette name associated to the sprite format. We're going to, again, have to re-export the sprites, but that's okay. I think this is going to work pretty well. So, and we'll step through this. So we go through, we're going to have the palette count. We will generate our palette files based on the palette count. We will then go through and create our palette, our tile positions, and associate sprite0.pal with it, where sprite0 is really the name of whatever the file is. So like scout0.pal, and then obviously again we can change that. And then what we do is when we load the sprite, instead of us relying on the palette being there, we will do the following, and it's pretty easy. We can I'm going to call something, I'm going to add a function called load palette. I'm going to go do this and pass the palette there, and we need to pass in the tile positions, because the tile positions is what actually holds the list of palettes that we might need. And so let's see, so that's an uint8 pointer palettes, or palette I should say, and then our tile position I actually just realized something. I'm calling it tile positions in the code here, but I'm calling it sprite positions in the JSON file, it looks like. I'm going to rename it just because it's going to create confusion later, I think, if I don't do that. That whole rename thing is one of the best things that Microsoft introduced into Visual Studio. All right, because it used to be you'd do a search and replace as carefully as you could, and you messed up things a lot of times. And this does a reasonable job. I think it does a better job in C#, but it does a pretty good job in C++ even, renaming things for you. The one thing it doesn't do is, which is kind of cool in C#, but just purely sort of visual thing, is in here when you rename it, it's renaming, giving you this. In C#, it kind of highlights it, and as you type it, it renames it in other places. It's cool. It's not actually necessary, but just a fun thing to mess with. All right, so the reason we're passing a pointer to a pointer is that we want to do the following. Want to come on. What I want to do is I want to do it this way, where at the end we just do palette equals temp. So we're allocating and populating the memory all in one shot this way. Memset temp 0 size of even 8 times pallet size. Okay. So now that we've got that allocated and properly initialized, let's loop through. Oh, we have no idea how many sprite positions there are. That's probably important. Because otherwise I have no idea how many of these we're loading. Oops. Now the other thing that we have to look at is that there is a problem. Oh yeah, that's not going to work. There is a problem because we don't want to load the same pallet multiple times. We just want to load it once in the order given. And the reason we want to load it once in the order given is because loading it in the order given is the order that it would be expected by the code when it indexes the image, right? So if we shift things around, we're changing the index of a color, which means that when we reload the image, that you're going to get the wrong colors. So all right, let's start with the assumption that we're not going to get the same one multiple times, which is a bad assumption, but we will start there nonetheless, just for the sake of keeping it simple. And we're just gonna, for pallet index, we're gonna plus equal for that every time. So here's what we want to do, right? We want our file handle. We want to open our file. And we're going to pass in, we're going to use positions I pallet. And then we're going to read the pallet file into the address of temp I, pallet index, 4 bytes. And then we're going to close the file. We're going to add a note here, check that file actually opens properly, and that will give us for the player, that'll work because the player has, well, that's not exactly true. That'll work. That'll work well enough for the now. I guess we do have to solve this now. I was going to say I don't want to have to solve a problem of if we've loaded the pallet or not already. But I don't see any other option right now, because even unless I explicitly create a specific example of a sprite that has two 8x8s with two different pallets, we're going to have incorrect data in our pallets. So how are we going to do this? I mean, the easiest way is just to have an array of strings that we can check the names of based on the number of positions to see if we've encountered that string before, with the assumption that we'll have no more than, if there are 7 total positions, we will assume, well, actually there can only be, because of the limitation of the colors, we can only have 4 separate palettes, which would be problematic anyway, but that's actually, so that bounds the problem pretty well. I mean, like normally you'd create a hash of the file name and you do your file comparison on that and see if that, then if the hash maps to an existing hash, that the file name is actually the same file, just for the sake of performance, especially if you were to be doing this over, say, thousands of file names, you wouldn't want to be doing, but this is 4. We're doing it for 4, so it's not really a big deal. So let's do this. Palette files for so it gives us our actually, wait a minute. Let me think about this for a second. Yeah, okay. It is for, yeah. It's for because of the maximum number of pallets we can have, not because of the number of total positions we can have. We could have 50 different, theoretically, we could have 64 different Sprite 8x8 tiles. If they're all using the same color, that should be okay. So, would it let me do that as an initialization? It will, okay. So what I want to do is I want to, before we do this, I want to, and again, this is not efficient to do if you're dealing with a large number of items, but we're dealing with 4 possible strings that we're checking against. It's okay. So let's see, if not string compare, do we want to do string case compare? I guess we don't care about the, oh, string compare I was confused which one is which, if it's Windows or Unix. We want to say, okay, we don't care about the case, we want to compare palette files J and total positions I palette, and if they are equal, if it's equal to 0, which is what that thing is, then we will let's see, then we are not going to load it. So found equals true, bool found equals false, found equals false, and then if not found. Right, so if we find it, we mark found as true, we break out because we don't need to check any of the other ones. We then, if we didn't find it, we will load it in, otherwise we will skip that one. Use underscore, okay. As you wish. Okay, so we load the sprite, and then we will go and load the palette based on the number of tiles and the tile positions. So let's first recreate the player sprite. All right, so png to sprite player.png. Let's export now the JSON file. Oops. Oh, yeah, that doesn't work. I've got to actually write the code to do that. So, there it is. We're missing the important step of actually exporting that to our JavaScript object notation. So let's do that. Simple enough. Current sprite, sprite positions, I palette, done. So assuming that we didn't make a mistake here. Yeah, there it is. Okay, cool. And then what we can see is that we actually have 4 separate palette files. Now, we know that, oh, you know what? That's pretty cool, actually. I wasn't expecting that. I just made a mistake. Let's. Okay. So what it did is it used the excuse me, used the index for the palette number, but the index is incrementing by 4, so we want to divide by 4 by doing 2 shifts, and then just to make sure that that actually works. Yeah, we got player 0 and player 1. And then what we want to do is we want to change this to that. And change those two. And then put a collision point somewhere at the top, so that the thing crashes into the bumper. So PNG to sprite, player PNG, player.json as the incoming data, and if we export it again, we should see the same thing. And we do. Okay, good. So now the real question is going to be, what happens when we try and view this? Okay, wow, cool. So that is actually reasonably good. So what we want to do is change this to that. Actually, no, we don't want to do that. We want to, how do we want to do this? So what we can do now is we can oh, you know what? There's actually a minor, there's going to be a minor problem with the way we're doing this. And the reason there's a problem is what I was manually accounting for before. But basically, so this is the background color. We have 4 colors, and then we have these colors, which are fine. That's not fine. We'll fix that in a second. But the issue is that there should be a color here and that color, I don't know why that just crashed, but okay. And that color is, shoot, that color is, what happened? That's weird. That color is the background color, and we're not accounting for that when we generate our palettes. So what are we trying to read here? Load palette. Palette index, palette file. Oh! Did I... wait, what? Palette. Player0.pal. You can't... Is it not able to find it? I guess not. Why does it not find it in... Oh, you know... Okay. This is that whole absolute path thing. It's annoying. Let's do this. Let's change the directory. Hey, Zorchenheimer. How's it going? So, so what we're going to do is we're going to get the parent path of... Actually, this is the wrong place to do it. We're going to change the directory based on when we're loading the sprite in our viewing process, because otherwise anything that's a relative path will not be visible, and that's no good. Let's see here. So let's convert Sprite to JSON, and why can I not find this? View Sprite, view mode. Where is it loading the sprite? Here, it's loading the sprite. So let's do this here instead. Let's get the parent directory of the target file name. I promise I can type. Damn it. And then the max file path is file folder name. All right, so we've got that. So now we have our parent directory, and then we want to just change to that. And like I said, it's because we have some relative, not this, it's because we have relative paths. I don't want to have to be dealing with looking those up, or I don't want to store them as absolute paths also. Okay, so that works, and then it should work here now too. Yeah, okay, good. So swap the palette there. That's good, and then 0E to that, And we can save that. But like I was saying before I was going down the other road of the paths, so the problem is now we have, you know, all these palettes, but we don't have the proper gap here for these colors, because when we generated our palette, we did not take into account this exception. I don't know what this is. I don't really care right now. So let's fix this problem with the palettes, and then we'll see if we can figure out what's causing that crash. So let's find the call to create Sprite, and what we're doing is we are in here loading our image palette by cycling through the colors, our indexed colors, right? And how are we going to do this? So we are trying to make unique colors and normalizing this. The only okay. This is actually should be pretty simple. So if j mod 4 is equal to 0, our palette if color map and 1 and color count is less than palette size, then do that and then add color count plus color map and 1 and then shift color map. Right, because, okay, and that's all fine. That's if we have the color count. So if the color's actually set and we haven't exceeded our color count or palette count, then we're going to set the value here. And then we add this, and then all I would say is we have to say if color count mod 4 is equal to 0, meaning we've hit the next boundary of the palette. Then we want to increment to the next one. I actually think we want to do that here regardless of if we set the color, because let's see, we don't care about the color of index 0. That's our transparent color, so we just want to skip it. I think that's probably the right approach. We will see in a moment. Let's do a full export again. And let's look at what that looks like before we do anything with JSON. Oh, right. No, I gotta actually export the JSON. I forgot. Because we hardcode the palette names for the initial export, and this is also wrong, so let's fix this. And then we can just steal that formatting, so we don't have to type quite as much. And let's put this at 8.0 and then regenerate it with the JSON file. Now let's take a look at it. Okay, so that looks better. I still don't know why it's loading the second pallet multiple times. It should only do it one time. But the other side benefit of having made that change is that now... No, I take that back. Interesting. Why... So we still have that problem where the pallets are... Actually, no, that's not that big a deal. Let's save that. Oh, that actually doesn't do anything now because the palette isn't changed by doing that. Okay, let's figure out what the crash is there, because that is... I assume it's some sort of memory issue where hovering over this is causing a problem. No, it just seems like it is. Here, let me reload this because I'm... Oh. Wait. That's on unload? So, are we corrupting a buffer here somewhere? Let's see. Exception thrown has triggered a problem. Open exception settings. No. What's my call stack look like here? Why? Why is this not triggering? Why isn't this triggering a problem at runtime? That's the question. And I guess we are saving the palette because it looks like it changed. Looks like it changed it. I'll take a look at. Yeah, and then I also see that it created a new one based on the fact that there was another one loaded, which is no good. All right, so let's manually modify this since it's simple enough to do to match what we had in the. Although I don't know that that's actually going to work very well. It's player 0. That's the top, and then this is the bottom, which would be player 1, and that would be 0E1020 3A. We don't actually care about the other values, that other value, because we don't use it for anything. Okay, so did I reverse it? Player 0. I must have messed up the player top, player bottom. No. Player 1 is the bottom. 0E1020. Oh, is it the last one I didn't change is actually the magenta color? No, so that's interesting. Palette 0, palette 1, and palette 1. I may just also be getting tired enough that I'm just messing up now. Now, I think the problem is that the way, because the order isn't guaranteed, the player pallets are not lining up anymore. So let's regenerate that. So this is 1 and 1, and this is 4 and 0, and I don't care about the collision points right now. And then let's take a look at that. What? Not sure what just happened. Is this a syntax error with the JavaScript? No. 408008. I'm doing this before. Strange. Why? I don't know why that tile isn't showing up. Let's look at this. Let's look at why it is generating the ND D3D. Okay, let's look at why it's still loading that palette multiple times. It shouldn't be, but it could be some silly. Let's see. So palette files J. Oh, because because I'm checking a list that never gets updated. That's why. I'll rename that. I don't actually like that name. I went to all this trouble to create this list that we're supposed to be updating and checking against, and I did not actually update that list. Okay, so this is now 1 and 1. Oh, I know what it is. I think I deleted the wrong Yeah, I think I deleted the wrong tile to import, and that's why it did that. So it may just be, like I said, I'm getting tired here, and I may have just made a silly mistake. So palette files, okay, so that now actually has something in it. Cool, so that seems to have triggered properly. Yeah, there we go. Okay, good. So it only loaded it once, and now I do that. And that saves. Oh, you know what? It might be the save. I wonder if it's the save that's the problem, because let's see something here. I wonder if that's corrupting memory. No, that didn't. That's interesting. Okay. I thought maybe that was corrupting memory, but apparently not. Sorry, let's do this again. Oh, we don't have those palette files anymore. I don't know why. Not sure why it's generating more Sprite palettes than I initially saw, but okay. All right, so we rotate that around, and then we change it to 0E, and then that is our palette. And so then what we can do is we can match that up with, so player, so this is, let's see. That's so weird that that is happening. Let's try this again. Run it in the debugger now and see if we get any clues. Okay, so palette 0 is this first one here, so let's do 0E 0004 00. Save that. And then palette 1 0010, so all that is good. So now when we reload this, stop it. We reload this, we should get the right colors back. Oh, but okay. I didn't, so it's a two-step process. Interesting. Okay. So the problem is that I updated the palette correctly, but the issue there is that even with doing that, if you don't save the updated palette, of course it doesn't have any impact on the image, which is what we want, even though we're manually modifying that file. So let's save that, and then go back in to this, and this is now 0E 0004 00, save, and that is the same, and then we save our sprite, and we close that, and then We go back and it should be good now. It is. Okay. So now the question is, what is the crash that we are seeing? Can I reproduce it? Seems to be related to I don't know what it's related to. It's weird. It seems to be able to reproduce it at will. It just seems to kind of happen. And it seems like it's in the direct 3D layer, which makes me a little concerned, but just a little bit. All right, so that is looking good. We're still not at the point where now we have the level properly allocating this palette and then assigning things to it, but we've now gained the ability to export a sprite with a independent palette that we can manage properly based on what we were talking about before. So there's our scout sprite. We can reassign and save that. The scout has 2 pallets for some reason, but let's get rid of that last one, just like we don't need this one. And what we can do is now export this sprite to JSON, and then we will have our scout metadata, and we have 1 scout palette, which we can then call enemy. Oh, I had one already. And now, anytime we import our scout ship, we can use this JSON file to get a consistent palette out of it. And then the enemies can similarly use the only thing I would say is we want to, all the enemies would use the same palette. All right, so, and then what we would do is we'd go into I think the only thing that I'm not doing correctly at this point is that it is still sort of arbitrarily determining the position based on just the content of the image. And what we would need to do is now, yeah, cool, so that reloaded it properly. What we would need to do now is in the asset tool, if it is getting a palette from the file, so if we are doing this, load the image palette, and we have let's see, so converting it to indexed gives us... So all I would say is what we want to do then is we want to say, okay, if we've loaded... So let me make a note of this. I'm going to wrap up for now because I'm done for tonight. So basically what we want to do is we want to say pass the pallets used if JSON metadata is provided, so that we don't arbitrarily choose any NES color that matches, but instead choose colors that are closest to the palette provided in the JSON. This means that we don't have to call load image palette below, but instead can use the one loaded from the JSON data / palette files. So just to kind of recap that part. So if we're doing this from scratch, where we've got an image we're bringing in where we've never brought it in before, we want to determine, right, like what's the palette and how does it map to the NES palette, or what are the colors and how do they map to the NES palette, and convert the image into an indexed image so that we can then work with it. If we have already done that and we've generated this metadata file where we're referencing a palette file, all we need to do is convert the image to indexed using the colors in the palettes available, so that we are ensuring that we are not accidentally referencing colors that are not part of that set of palette colors, right? Because we don't, the whole point of having these files and this metadata is to not have to worry about the order of the colors coming in from the image anymore, or one of the main parts of it, I should say. So once we're good with that, then we should be getting consistent loads of, like, that scout chip should come in with I think this is going to be the player ship. This scout chip should come in every time with just these 4 colors associated to it in that order, no matter how many times we reconvert from PNG to our Sprite format. The idea, again, being that we want to be consistent across conversions, so that if we modify this PNG to tweak the way it looks, or any of the PNGs, that we don't have to worry about reformatting the colors and re-indexing the image and re-updating the palettes, and then palettes have the same colors but not in the same order, so we're just, it's going to make the process of re-updating the assets much simpler. So that's it for tonight. That hopefully gets us in a good position where we can now start providing the palettes used for each of these levels that we're going to export in the game, allowing us to deal with things like the starting palette properly, and then, as I mentioned, potentially adding things like a palette change layer or something within the map that we will key off of to do the dynamic palette swaps, rather than trying to juggle all the different palettes by automatically by analyzing the content of the map and the sprites and stuff like that. This gives us control over it, but without going crazy and making it so complicated that we're going to spend too much time debugging why things didn't flip over automatically, and then on the same by the same token, we will have explicit directions for when we swap the pallets, which will be easily updated within the map, most likely, or within the level flow, so that we don't have to, so that it's easy to make those changes as we go, instead of having to worry about, accidentally exceeding our pallet counts and stuff like that. So, as always, thank you for watching. If you'd like to say hello or ask questions or just, I don't know, reach out to me. I'm on Twitter at Clairvis. I will post this recording on YouTube as soon as I end it. And you feel free to ask questions and post comments on the videos. People have been doing that, and it's great. I love that people are getting something out of these videos. I'm also on Nintendo Age as what am I under there? I'm as Clairvis on the Nintendo Age. Or no, am I? I don't remember. Yeah, that's how tired I am. I don't even remember what I'm on there as. It's I think it's actually Zelius, but whichever, you'll find me. You can ask. I'll respond. I'm usually on there. Sorry, and then my email is on there at zelius@gmail.com. Anyway, have a great weekend. Thanks again for watching, and I will catch you next Monday when we pick up again and get this working for the levels, and hopefully move on to some really cool stuff with the enemies and palette animations and more game programming. So thanks again. Have a good night. See you later.